me see. Do you guys see R now?
Yes.
Okay, so I'm going to assume that you guys are able to install R and you have it set up. So I will show you a few things. I just want to make sure that everybody can do some basic stuff, and then I want to talk about the data in the project, and then I can answer any additional questions.
So the biggest issue, I think, is actually finding out all the attributes and all the calls, subprograms that are available.
Mm-hmm. Yeah. Like I usually end up just Googling.
Okay.
If there's a particular algorithm I want, the cool thing about R is there's usually so many different packages that can do it. Like I do a lot of structural equation modeling, and there's multiple packages that can do that. You have the SEM package, which is structural equation modeling, PLS, which is partial least squares, and then there's more than that, but
yeah, I did find three actuarial packages.
Great.
But again, it's trying to get going with them is probably the harder part.
Yeah, I usually try to find an example close to what I'm trying to do in R, and then I try to adapt what I want to do, or adapt the code to what I want to do, and then through editing it and debugging it, eventually I'll get to get the answers that I need from it.
So I have a question that's I was wondering, because you keep talking about algorithms, in the past 2 weeks I've been learning about them. How do you tell which algorithm you want to use for which thing?
We're actually going to talk about that in the data mining class. So
okay. Sweet.
We're going to talk about when do you use a support vector machine, when do you use a neural network, but that's what we're going to do in the data mining class. At this level, like I said, when I designed this class, I didn't know what level of R programming the students were going to have, so I tried to go very easy in this one, and then the next class will be very hard. But yeah, application of when you use the different models is what we'll talk about in the next class.
Okay.
So do you guys know if you use Control L, you can clear out your console? I find that helps. Because I hate when it's super messy, but so
Control L.
Sure. Control L, yeah, it clears out the console down here. I actually have a special set of code over here that will clear out everything, like your environment, your history, and all that. But I don't want to run it because I'm doing a bunch of research right now, and I don't want to lose. But I can paste that because usually when you have projects going, you don't want to have like you accidentally use a variable from another project. But I wanted to double check that everybody knows how to install packages. So first off, I guess I should say, you know how to open a new R script, and it'll pop up in this like upper left quadrant of your screen. And then how to install a package. Oops, I already have that one installed. But install.packages should install it. And then to access everything in that package, you have to use the library function. And it'll load that library. And then you can access things in it, such as histogram with, oops, it's not going to let me do it, of course.
Do you have to download the packages, or can you run them through the internet, like a URL link?
I'm pretty sure you have to install the packages you're going to use.
Okay.
Yeah, I think it said that on the Mirror, whatever, with Mirror site, that they were being installed to the C drive, local drive.
Does R use like notebooks like Python does, or is it just use like a console like this?
You can write an R script in like Notepad if you wanted to, and you can open it up in here and you can run it. So and you can execute an R script that's very similar to like what you can do in Python.
But not
I
like
just
a
like
Python Jupyter where they have the Jupyter notebook online and you can type in your code and then people can share it.
I think they do have something like that. I'm trying to remember.
Oh,
A lot of like what you see people doing with R code is on like GitHub, and they'll post all their code up there, and you pull it down into your R and run it.
oh, okay, okay.
But
Now, when you run the install the packages, do you have to? I don't mean to be a pain, but I'm used to coding with Python. Do you have to run? Can you run certain parts of just install certain parts of the package, or do you got to install the whole package?
I think it installs the whole package. I've never tried to install part of it. What you'll end up doing is you'll end up masking. Cannot get this to work now. I just ran all this code. But generally, you'll install the whole package, and then when you load the library up, it will give you a set of functions you can use. But sometimes if you load two libraries that have the same name for a function, but they do different things, and one will get masked, and that's something you have to watch out for when you're using R, is that you don't end up running the wrong function in your R script. So I assume you guys know how to get the data in to R. I usually do everything in a read.csv and then file.choose. And this makes it where you can just go select the code. So in this case,
Okay. No, actually, I didn't have to bring any data in yet.
so that's the data that we're going to talk about. But I like doing it this way because it works on all versions. And if you have a Mac computer, you have to write the file path differently than you have to write it on a Windows computer. So I just started doing it with the read.csv file.choose.
When you use that command, do you have to do it each time, or is it when you do the read.csv file choose, is the data in there and now it's stuck in there?
Yeah, now the data is here.
Okay.
So it's in your environment.
And we don't have to install a package to open up CSV files on R, correct?
I don't think so. I think that's in the default packages.
Sorry, Bruce, I'm just asking these questions because I'm used to coding in Python. You got to install these packages to get the data out of a data set.
No, it's all right. I mean, there's only, I think, 2 people in here, right?
Right.
Yeah. So, I mean, the live session is for you guys, so if there's any way I can help, just let me know. So that's how you get the data in, and then there's various, well, I think next week is when you have to do the summary statistics. This week I just wanted to make sure you guys could get the data into R and look at it and start doing some background research. We can talk a little bit about data.
Yes.
So this should be a month's worth of data. This is at midnight, and then 1 a.m., 2 a.m. So we have it hourly. The first one is the number of ED beds.
Well, that's not actually explicit.
What do you mean?
Hourly?
Yeah, it's
Okay. Formatting.
I have each row represents what the variables we're doing in that particular hour. So you'll notice that through the whole data set, the first two variables stay the same. That's the number of ED beds in the emergency department at this particular hospital. The second variable is the number of inpatient beds in the hospital. So that's all the beds that are not in the ED and those that are actually on the hospital floors.
Those are total
So
beds.
why would they stay the same? I mean, you can actually have, I mean, you can't increase more than, well, actually you can by doubling up, and you can decrease by having, a contaminated room or
this is just
contaminated bed.
the beds that existed. So they had 532 beds on the hospital floors, and that didn't go up or down because they didn't add or take away beds. Now when we get to here, that's the number of ED patients. So you'll see that 57 patients were in, so 57 of these 72 beds were taken up. And if you'll get down here, you'll start to see effects of overcrowding. There's 78 patients, but we only had 72 beds. 105 patients, but only 72 beds. And these are patients actually in the emergency department beds or hall
So if you don't mind me
spaces.
asking,
Yeah.
what does a hospital do with that? Do they grab another bed from somewhere else and bring it in the ER to put the patient on, or?
They keep them on gurneys.
They'll put them anywhere. I mean, they can end up in just a chair. They can end up on a hall bed. I mean, this problem, emergency department overcrowding, is a very big deal in the healthcare systems worldwide right now. So how they go about doing that is not necessarily best practice, but that's why there's a lot of research going into how we can make this problem better.
Okay, I was just curious because I remember when I had to take my wife to the ER at University of Florida at Shands.
Mm-hmm.
They had people sitting on chairs, grabbing beds from everywhere. It was packed. But I was reading this. So those people in the chairs and then those beds would be counted as emergency department patients because they were already checked in, correct?
Yeah, they're past triage, so they're not in the waiting room. They are in the emergency department, either waiting to see a physician or they've seen the physician. They're waiting for the disposition of whether they're going to get discharged or they're going to go to a floor bed. So then the next column is the number of ED patients waiting to go to so they're in the emergency department bed now, and these are the ones that are just taking up space and waiting in the ED until they can move to their floor bed. This is the number of critical care patients. So these are patients that are taking up more resources. So nurses in the ED can, let's say they normally take care of 5 patients if they're at a certain level, but if we end up with critical care patients in there, then the nurse to patient ratio will drop, and maybe they're only taking care of 1 or 2 patients depending on how critical that patient is. So that's how that variable affects this.
So, got a question for you.
Mm-hmm.
What about ins and outs? So you have someone come in and leave in the same hour. That would just disappear, drop off?
Based on how they recorded the data, yeah, because all I have is it by hourly. When I get to the other two spreadsheets, we can talk a little bit more about how you could get more accurate with that. These last two are times. This is the amount of time it takes from a patient that comes into the door and how long it takes for them to get triaged into an ED bed. That's what it's called, the door to bed time. And the last one is the longest amount of admit time. So a patient sitting in the ED, how long is it taking the longest patient to go from an ED bed to a floor bed?
What is that time in measure? Is that minutes, hours? That's hours?
Yeah. So we have two kind of dimensions here. We have like volume, how many patients are here, and then over here we have throughput. How long is it taking to move those patients through the emergency department?
So it sounds like a regular queuing problem.
Kind of.
No, not quite, because you're actually taking snapshots as opposed to flows. You're taking a snapshot at t equals 1, 2, 3, and 4, which are hour apart, and the column G is the one closest to that, or the one prior, the last one prior to that snapshot. So row 12, the last one prior to the 11th hour was 21 minutes. So it's not quite like queuing because you don't have flows going in and out and getting labor times for everyone.
Okay, yeah, I see what you're talking about. I didn't read that part where it said door to bedtime for last ED patient. I kind of assumed that was like an average. Oh, I got it now. Just pointing that out. That probably would have screwed up my analysis.
Yeah. So the next set is, this is all the patients that came through the ED in that month.
Okay.
So when they arrived, when they were put in an ED room, then you have when or if they got a disposition to go to the floor, when they were ready to go to the floor, and finally when they were put on the floor. So you have timestamps for how each of these patients moved through the ER.
Okay, so you add this together, now you have a queuing problem.
Well, you could simulate every single patient exactly how they went through, or you could develop a random generator of based on the distribution of how these go. But I don't think we're going to focus on simulation in this class.
So when it goes to the ED arrive in the ED rooms, what does it mean when they drop off? Like some of these don't continue on.
If, like this one, they went to the ED room and then they are no longer in the system because they were kicked out of the ER basically, or the ED. So they were not given a disposition to go to the floor. They came in for something, and then the doctor decided they didn't need emergency care or hospital level care.
Well, wouldn't it be that they got repaired and they were sent on their way also? I mean, sometimes you get fixed in the emergency room and then they send you on your way.
Yeah, that's what I would say when you're getting, say, these timestamps. That's probably more what's happened there.
Don't necessarily know.
So what are they doing with the drop off? Is there a variable that we're not seeing? Admit to disposition selected, ready for admit. Like the top one, row 2, I'm not understanding, where do they go? Are they still in the ER room for the whole month?
I think I would assume they are discharged. The only timestamps I was given for these. So there's a lot more going on that would have been nice if we had known like patient diagnosis. That would have been really helpful with this data set, but they were only willing to give me so much data, and definitely nothing that had a patient identifier on it.
Oh, this is a real data set that we're using?
Yeah. This is all anonymized patient IDs. I think the timestamps are shifted so you can't identify the patients, but yeah, this is all real data from a hospital.
Like something from Kaggle or something.
No. That's why this is real.
Oh, I was like, oh, wow. Okay. Wow.
So that's why I thought this would be a cool project, because this is as close as I can get you to being a real analyst without it being your job. The last one that you'll probably be interested in is the actual NEDOC score. It stands for National Emergency Department Overcrowding Score. And I think I pulled up, see if I can find here. So there's different calculators out there. This particular hospital had their own calculator, but this scale tells you the state of crowdedness in the emergency department, where if it's between 0 and 20, it's not busy. 21 to 60 is busy. 61 to 100 is extremely busy, but not overcrowded. Mostly what we're interested in is when it's over 100. And that's when it's overcrowded, severely overcrowded, or dangerously overcrowded, or what's the other term? Disaster level overcrowding is what.
Basically, this is the first tab.
The what?
This is basically the input for the first worksheet.
Mm-hmm.
So I have a question. How would you rank if in a catastrophe like 9/11 and they actually had people that went to the hospital, what would you rank that as? Would that be like the red zone or the orange zone?
You don't even have to have something like a mass casualty to occur to have this disaster level overcrowding. That's why it's
okay.
So you see, like, they're exceeding the 200 limit. I think in this data set, they have disaster level overcrowding 13 days out of 31.
Now, even if they, because looking at the data set, they got it, it's kind of overcrowded a little bit. When do they, if it crowds over once, do they count that as a day? Or?
You have, I think they're recording the NEDOC score every 15 minutes. So
if they hit overcrowded in any time within that 15 minutes of that day, they'll count the day or no?
They don't necessarily count it as a day, it's a time period. And what happens is when they get to this overcrowding level, they do something called a code yellow. And that's when they have processes in place to decompress the emergency department. So usually they very quickly start discharging floor level patients so they can move ED patients up, or they try to discharge patients in the ED that don't need that level of care, or they'll try to transfer patients, etc. So
if you get discharged quickly from floor patients, then you know they're overbusy and you might get screwed. That's what I'm getting out of this.
Yeah. Our healthcare system is in terrible shape. It's not.
And I'm not in the States.
So hopefully you guys understand a little bit more about the data that you have to work with and the problem. I'll continue to try to find more information, but if you go on to like Google Scholar, you can find research papers written on the topic, or look just using Google to try to find out more about emergency department overcrowding. And then the goal is to take the data that I've given you and develop some kind of model that you can analyze and then make that suggestion, or make a suggestion of how this hospital could decrease the amount of time they're in disaster level overcrowding.
Now, for the assignment for this week, when we have to write that paper, is the terminology, like the emergency department patients waiting, is the jargon kind of the same throughout? So when I go and Google, what does number of ED PTS mean, or some of these other terminologies mean? Will that be standard across all healthcare or no?
I don't know if they'll use this, because I might have typed this up based on what the information I had. I got this data a couple years ago. So, but emergency department beds, inpatient beds, patients, just, I guess, send me an email if you run into a problem with what the variables are. They should be the variables associated with the NEDOC calculator or the NEDOC scores.
Okay, so I can find most of the jargon on the NEDOCs and kind of go from there.
Start researching the NEDOCs, you'll find out more about it.
Okay.
So let's see. I can get here. So yeah, this week I'm just write a paper and try to explore, because obviously if you don't have a background in healthcare and you were a consultant and you were trying to get this project, then do what you would have to do to learn as much about it as possible. And then feel free to ask me any questions about it. Pull your data into R and make sure you can look at it there, because the next assignment is going to be actually starting to analyze the data.
So you just want us to pull it in like you did right there and kind of overlook the table that it showed up on?
However you want to pull it in, and then manipulate it and look at it. Just start to get comfortable with the data and R, and then in the next like 2 weeks we'll learn more about what we can do with that data to start analyzing it.